Hello everyone, welcome to my presentation. First of all, let me thank you all for coming here today. Let me start by saying a few words about my own background. This is Nizar Bustani. I'm a student in Gaziantep University Structure Department on Civil Engineering. As you can see on the screen, our topic today is mechanical properties of normal and steel fiber reinforced lightweight geopolymer concrete. We will start with research aim. In line with the current direction to decrease the quantities of the natural resources required in concrete production by using waste materials such as slag and fly ash. This research aimed to produce slag-based geopolymer concrete using lightweight artificial aggregate, which has been manufactured from slag in order to reduce the adverse environmental effects. The properties and amount of lightweight aggregates used to have a significant impact on the properties of the concrete. Therefore, in this study, experimental research was conducted to investigate the impacts of replacing coarse river aggregate with one type of lightweight aggregate on the properties of concrete produced with and without steel fibers. The objectives of this research shows designate the background on the elements utilized to produce fiber reinforced lightweight geopolymer concrete. Second, assess the fresh and hardened properties of geopolymer concrete produced by replacing coarse river aggregate with two types of aggregates. And the final, investigate the effects of the addition of steel fibers on the characteristics of artificial lightweight aggregate by applying different tests such as splitting, tensile strengths, and compressive strengths. As you can see in this slide, how to produce the aggregates. In our work, the coarse aggregate has been prepared using slag and cement by cold bonding process for using it in geopolymer concrete. In this work, also an extensive study on the recycling of slag by means of cold bonding pelletization is presented. This process has been applied to mix in which the slag content has been varied from 90% slag plus 10% cement. Cold bonding pelletization is performed by means of the rotting and tilting plate. The water was sprayed manually by means of the sprayer, and the percentage of the wastage was very small. As you can see, the slag, the lightweight aggregate of slag and cement. After producing the aggregate, the period of curing had been taken 28 days to be ready for using in the mixes. Before casting the concrete, before using this aggregate, the aggregate had been put into the water for 24 hours. After 24 hours, the aggregates had been dried under the sun for 1 hour before using. This is the mixing process. We started with the first step, adding the sand and fly ash, and the second step we mix it, and in the third step and fourth step we added the aggregates of slag and mix it. In the next steps we added the steel fiber and the sodium silicate, as you can see in the picture. Let me show this the mixture. This adding the sodium silicate for the mixture. And after that, adding the steel fiber for this mixture. We have two types of the concrete with steel fiber, and concrete without steel fiber. After the casting, we test with slump test for check the workability of this mortar, as you can see in this slide. And this is the modules photos before casting. We have a cube, cylinder, and prisms. This is the modules after the casting, and this is samples after casting and after. This is as you can see in this slide. You can see the concrete photos before testing the samples for strength and splitting tensile tests. As you can see in this picture, the concrete or the samples photos after the testing. This is show the 0.05% steel fiber in these samples. And in the next slide, you can see the photos for samples that contain 1% steel fiber in this mortar. And for the results in this research, as you can see, we have two types, and we have two types. We have the one for 0.5% steel fiber, and for 1% steel fiber. You can see the results for the compressive strength and for splitting tensile strength in the mixes for 7 days and for after 28 days. As you can see in this slide, you can see the first mix that show the value for 29.96 megapascal, and the high value for 46.12 after 7 days of the casting, and for after 28 days, the value of the compressive strength show the first mix show the value is 45.97 megapascal, and the high value for 58.7 megapascal. And the other test for splitting tensile strength in the after the 7th day, we have 2.02 for the first mix, and for the 5th mix we have 3.93 megapascal. And after that 28 days, we have the high value for splitting tensile strength is 5.67 megapascal. And finally, we'll talk about the conclusion for this research. It can be concluded the performance of lightweight aggregate geopolymer close to normal ordinary Portland cement concrete in terms of workability and mechanical properties. Moreover, it can be approved these properties for construction application in sites. Second, the presence of the steel fiber in lightweight aggregate geopolymer mixture with 0.5% and 1% significantly improving of mechanical properties. However, the slightly decreased of 1% steel fiber mixture workability. And the third, the highly bond between aggregate, artificial aggregate, and steel fiber with geopolymer matrix was observed in all mixtures. Fourth, the compositive strengths are ranged between 29.96 and 58.17 megapascal at 7 and 28 days respectively. And finally, the splitting tensile strengths are ranged between 2.0 and 5.67 megapascal at 7 and 28 days respectively. Finally, I will thank you for your listening.